Yes, thank you very much. You can see my screen?
Yeah.
Okay.
In here, yeah.
And thank you very much for putting on the program. I was also, of course, very much looking forward to it in person last year, but at least we have it online now. So I will present a laboratory experiment. It's called the Stabilizing Effects of Publishing Strategic Central Bank Projections, and it's joined with Stefan Arends, who is at the Free University Berlin, and Michele Tetemazzi, who is no longer in research currently. So the motivation is based on two facts that you well know. So first of all, expectations of households, firms, and so forth are very important for the effectiveness of monetary policy, both normal times with general interest rate policy, but also especially when we talk about forward guidance, it's all about expectations. And secondly, central banks, we observe over the last decades, have become increasingly communicative and share their general policy views in inflation targeting regimes, but also are more transparent about their decision making and the factors that come into this. And a pivotal aspect in this respect is that they also publish macro projections. So, for example, the FOMC publishes real GDP, unemployment, inflation, and interest rate forecasts. So why do they do this? There are different rationales that we could think of. One would be that central banks have superior information, at least compared to some part of the private sector, and that publishing these forecasts help to reduce private sector uncertainty and leads to more desirable economic outcomes. Another thing, an additional reason could be that by publishing forecasts, the central bank might also try to a little bit strategically influence private sector expectations by having some bias on this forecast. So there's some empirical papers also that find that central bank projections for inflation are somewhat biased in the direction of the inflation target compared to other forecasting institutions. And this is something that we find particularly interesting, especially also from a theoretical point of view. So we are not interested in to what extent are central banks actually doing this, but we're interested in could a central bank do this and would that work, like manipulate the forecast that they submit or that they publish and thereby use this as an additional tool to stabilize the economy. But of course, there we must be aware of credibility as well. So there's a trade-off then between, on the one hand, trying to actively manage expectations with biased forecasts, but on the other hand, if the forecasts are too biased, then the people will no longer believe that the central bank is actually a credible forecaster. That the forecasts are reasonable and make any sense and should be trusted. So a trade-off between this active management and credibility. And these aspects is what we want to study in the laboratory. So in particular, we perform a learning to forecast laboratory experiment. I will come to the details of that. And we study the active management of private sector expectations by means of publishing official public central bank projections in this laboratory setting. And we do this in a New Keynesian economy, so a New Keynesian model in the laboratory, and we focus on inflation expectations only to keep things simpler. So we model output expectations rather than let subjects form them. So before I come to more of what we actually do, let me talk a bit about the research questions. So the first thing that we would wonder is, okay, in a laboratory experiment where subjects form expectations and are presented with official public central bank forecasts, are they influenced at all by these published central bank forecasts? And also, how does this depend on what kind of forecasts are actually published, as we will see in different treatments? And then secondly, okay, if this has any effect at all, can this publishing of forecasts then be used as an additional policy instrument and help to stabilize the economy both in normal times and also at the effective lower bound in times of severe economic stress, where basically traditional instruments become ineffective and where this would be an even more useful tool if it works. And then finally, we are concerned with this issue of credibility that I mentioned. So how does the effectiveness of this expectation management actually depend on the credibility of the projections? So to give a preview of the results, first two questions, yes, we can influence expectations and this helps to stabilize the economy. And then regarding credibility, this is indeed an important factor, but I will also show you that just focusing on full credibility at the cost of not doing any strategic manipulation is not optimal. There's a benefit of losing some credibility and actively trying to steer expectations that works well, as I'll show you. In the laboratory, at least. So why a laboratory experiment? Well, here we can control the economic environment where subjects form their expectations. And this helps us with different treatments to clearly identify what the impact of different kinds of published projections are on the expectation formation and also on then the dynamics of the simulated economy. And of course, a field experiment would also be very interesting, but this is not feasible. No central bank would agree to try out different untested strategies of deception and manipulation and bias their forecast in ways that we think are interesting for research. So this is not an option, and we are left with the laboratory. But luckily, there's a recent study by Cornell and Hubert who compare expectations formed in such learning to forecast experiments with survey expectations of inflation, and along several dimensions, they do not find fundamental differences. So there seems to be some external validity to the expectations formed in the setting that we have here. So literature, I won't go into the first 2 points, but just to highlight the most related papers are a series of papers mainly by Luba Peterson, who also studies in a learning to forecast New Keynesian environment in a laboratory central bank communication. But the main difference is that we focus on these strategic, deliberately biased projections that try to manipulate or steer private sector expectations. That has not been done as such before. So then how does a learning to focus experiment?
Can I just add one small comment that I think is really relevant to what you're describing. So when you're saying that central banks tend to have forecasts that are biased towards their target, that's almost a credibility requirement for them, right? Imagine I'm the central bank and I tell you, we predict that inflation is going to be way below target, but I don't take any action. You know, that's immediately going to signal, you know, in a way that, say, Goldman Sachs or some of these other private sector forecasters don't necessarily have to. But you know, I was always struck, and this is, of course, never made public, but like when I worked in a central bank that was an inflation targeter, while we were doing the forecast, there were times that it would come in that the forecast for inflation at the 2-year horizon would be away from the target. But they're the times when you sort of knew then that the central bank would take action, and they would take enough action to bring it back to target at that horizon. Of course, it doesn't have to be perfectly back at the horizon. And in the last few years, we've allowed this sort of the range of times over which you bring inflation back to target to vary a little bit. So there is some variation, but I think it's important that, you know, you're aware that the credibility also points to them ensuring they have target hitting forecasts. Anyway.
Yeah, that's a very good point. Of course, there's an endogeneity for them between the forecast and their policy, and they can actively change their forecast without biasing them by changing their intended policy. That's a very good point. Also related, which I didn't mention, I have one more thing first. So when we talk about credibility here, we focus purely on the credibility as a forecaster in terms of forecasting performance. And of course, there are many different aspects of credibility and regarding commitment or not, and regarding the credibility of being able to achieve the target, as you mentioned now. But in this experiment, when I use credibility, this will only imply the credibility of the forecast as being accurate forecast. And one more thing that I wanted to say, yeah, so also the central bank in our experiment, I can quickly show you that already on the next slide, will be committed to a Taylor rule. So at least in normal times, this implies that a different forecast for inflation also means that they expect to have a different interest rate path. So in this sense, these published inflation projections can be seen as also as a form of Delphic forward guidance to make it more explicitly related to the title of the workshop. Okay, that being said, back to this slide. So how does the learning to forecast experiment work? So there are different subjects, in our case 6 or 7, that form inflation forecasts. And in every period they need to do this for the next period, and we aggregate their forecasts into aggregate inflation expectations. And this feeds back into the economy, into the new Keynesian equations on the next slide that I already briefly showed you. And that means that there is some positive feedback in the experiment. If people expect higher inflation for the next period, then current inflation will actually already be higher now, and vice versa. So that's the main setting. As I said, output expectations we just model, and inflation expectations enter in the IS curve and in the Phillips curve, and that then drives the evolution of the economy from period to period. Then the calibration, I just want to highlight that we have an inflation target very close to 0 to be in line with the assumed 0 inflation for the linearization, but we slightly deviate from this to give not a too easy focal point for inflation where it may end up for subjects to coordinate on.
Joep, sorry, could you go back?
Yeah.
I was just wondering, so if I understand correctly, the expectations are essentially empirical. You get them from the lab and you plug them into these equations?
Yes.
And I'm just looking at the Taylor rule thinking, is there like a 1 period lag in the transmission of the interest rate? Because you first have to observe the expectations, then you get output gap and inflation, and only then do you get the interest rate. So I'm just thinking about the timing of the interest rate.
Yeah, so basically I can already go to the timing here, so forget this part for now, we'll come to that next. But basically within each period, the forecasters form their expectations, then we have the expectations, and then we can basically do everything. So then we aggregate everything at the end of the period by first plugging them in here, and basically we then solve the system of 3 equations simultaneously. Of course, the interest rate also affects output, but the only unknowns in this 3 equation system are these inflation expectations.
Yeah, I see now. Yeah, thanks.
And then, yeah. So how does the experiment further work? So we have economies of 7 subjects, and they are completely independent of other economies. These are just different observations. So subjects are together with 7 in total. And at the beginning, everybody is a professional forecaster. And in 2 slides, I will tell more about them, or next slide. And they need to make these inflation forecasts that enter these equations. And then after 8 periods, which is the initial state, that is not so important actually for the analysis, then we choose the best forecaster to become the central bank forecaster. So he gets a new role. And then the main part of the experiment starts. And this main part, where there are 6 professional forecasters and 1 central bank forecaster, is divided in 2 parts, stage 2 and stage 3. And the difference is that stage 2, which is 20 periods, simulates normal times where we do not have a crisis, no effectively lower bound. And then in stage 3, we manipulate the time series a bit. We give some bad shocks that lead to a big recession and to a binding lower bound. And these shocks last for 4 periods. And then we see also when we're still in the recession, how quickly do we recover, and then the experiment ends. So stage 2 is normal times, stage 3 is times of severe economic stress, and we see how well the publication of projections works in both cases. Then these professional forecasters, so we tell them they are employed at a private company and need to provide inflation forecasts. That's their job, and they're paid based on the accuracy of their forecasts with this formula. Then they get qualitative information of the economy, so we do not give them equations because that might just confuse them if they are not master students, but we tell them how the economy works. And then we also tell them, explain them clearly the feedback of the expectation. So higher inflation expectations leads to also higher current inflation and so forth. Then they also see in each period the historical development of the economy. So maybe it's interesting to give a quick look at the screen. So we see this is actually the initial time series that we give them. And then later on each period, there's new time series added. So here we have interest rate and output, and there we have inflation and their inflation expectations. And they also have it in a table. And note, which will also be important later, is that actually we do not start around 0. We deliberately give them an upward trend so that they may have high expectations when they start the experiment. And we're interested in how quickly converges the economy back to the inflation target, and how does it depend also on the publications. So if you would start around the inflation target, probably there would not be much need for this tool of stabilizing with published forecasts. Okay, back to this slide. So they see this historical development, and then finally we give them, depending on the treatment, also an official central bank inflation projection, which they see on their screen and say the central bank projects this number. And then they may ignore this information, they may copy it, or they may partly use it as they wish. And we're interested in what they...
Can I ask you to clarify? Do they know that that central bank inflation projection is chosen as the best forecaster up to date?
So it's not up to date, it's the best forecaster of the first 7 periods. And then
Exactly.
that one remains forever. And yes, they do know this.
It would be interesting to tell them that's true or that's just been picked at random. Because you could think they would react differently to knowing that the best of the 7 is now giving forecasts rather than a random person out of the 7.
Yes, that would indeed also be an interesting other treatment. So what I can tell you already a little bit in this direction is that we do have different treatments that do not vary in this direction, but still vary a bit about like how people would view the reputation of this projection. Because in treatment 2, we have this best chosen human subject that becomes that gives these central bank forecasts. But then in treatment 3, we say, well, what if it's actually not human? How would people react to it if they know that this is actually a computer algorithm? So we have a computer algorithm that provides a forecast, and we publish these forecasts rather than the forecast of the subject at the central banker. So that already gives something in the direction that you're aiming for. But yeah, what you're saying, like just what they think about the subject and having another treatment there would also be interesting. Thank you. Now that I'm at the treatments, these are treatment 2 and 3. Treatment 1 is no published projection, so they do not have any information in this direction, just the other information. So that's a control treatment. And treatment 4, there we also tell them it's a computer algorithm, but actually there it's a random forecast, so also drawn by the computer, but they make no sense at all. And we also want to see the effect of that, whether people learn to ignore that or what happens there. Then this slide I was already briefly regarding the professional forecasters and then aggregating and going to the next period. The first part of within each period is that the central bank subject moves first. So first he gets time to form his forecast. Then in treatment 2, this is shown to the others. And in not treatment 2, something else is shown to the others, but the sequence of events remains the same. Okay, then this human central bank subject that makes these forecasts, he's not just the best forecaster, but he also gets additional information, and also the other subjects know this. So this gives him some more credibility, but also makes him do maybe a more interesting, better job at what we're interested in, namely whether he can steer the economy towards the target. So we tell him that his objective is to minimize deviations of inflation from the target and to maximize his credibility. So giving accurate forecasts is not an objective that he has, but maintaining credibility is. So for that, he may decide that he needs to make accurate forecasts because otherwise people don't trust him. Then the 3 information pieces that we give him is, first of all, a data-driven forecast where we basically use all our computational tools based on the model equations, parameterization, and on modeling as accurately as we can. So as researchers, how inflation expectations are actually formed. And based on this, we tell the subject, so the data-driven forecast is the most likely outcome of future inflation based on everything that we know. And this is actually relatively good forecast, and much better than the subject could form himself without knowing the model equations and so forth. And this may help him to build up credibility. If he follows that, then his forecast would become more accurate and people might trust him more. Then the second piece of information that we give him is something that we call required for target. And we tell him, well, basically, if you would like to achieve the inflation target in this period, then the expectations in this period about next period should be this number. We can just get that from the model equations. We can just calculate what should inflation expectations be in order for inflation to be something, namely the target. We can calculate that as researchers, and we give him what should expectations actually be if you want to achieve your target now. And if we would bias basically his expectations away from the data-driven forecast in that direction, that would help him to stabilize the economy. And then finally, we give him a credibility index that is a measure of how close in the past other subjects were to his published forecast. So whether they were kind of following it or not, and that may help him to decide whether he wants to focus on building up more credibility with the data-driven forecast, or whether he has enough credibility and wants to focus on stabilizing.
On the credibility index, do I understand correctly that it's based on the period before this person became the central bank?
No, it's based on, well, so in the first few periods, there's not an interesting credibility index, but then the experiment lasts actually for many periods, and later it's always based on the most recent 4 periods.
So the other agents are aware that this is the central bank, and that's when the credibility index is built.
Yes, that's exactly. And the computer algorithm that we define in treatment 3 is actually based on the same information pieces, and we just balance them as we think would be good. I think I need to hurry up a bit, so let me skip that. Then the hypotheses are, first of all, we think, and this is also the outline of the following slides. So I will present results answering these 4 hypotheses, And the first one is that in treatment 2 and 3, where we have these strategic projections, we think that this will coordinate private sector expectations, so reduce the dispersion, the disagreement. And random projections we do think will not have this effect. So treatment 4. Then hypothesis 2 is that we think it will also, treatment 2 and 3 will stabilize the economy, both in normal times, so we don't have the bad shocks, but also in times of severe economic stress. And again, we think random projections should not have this desirable effect. And then hypothesis 3 and 4 about credibility. So first of all, we think that the ability of the central bank to stabilize the economy positively depends on its credibility. And finally, for treatment 4, we think that credibility positively depends on forecasting accuracy. So this is what we assumed basically when we have the data-driven forecast, that may build up credibility, but we also explicitly test this. So the first hypothesis is dispersion, cross-sectional dispersion among forecasters reduced if we have these strategic projections. So we do a regression based on Ehrman et al. And Hubert, where we regress cross-sectional dispersion on its lag and on some controls and on the main variable of interest, which is whether there's a projection available or not. And in treatment 1, there's no projection, and in the others there is. So if we focus on column 2, there we just have treatment 1 and treatment 2. So there, if there's a projection available, then this is the projection of the human central banker that is published. So in column 2, this coefficient says what does a human central banker for published forecasts do to dispersion compared to having no forecast in the control treatment. And there we see it's significant and negative, so it reduces dispersion. The same for treatment 3. And in treatment 4, actually, we see this increases dispersion. So just doing some random projections leads to more dispersion because some people follow it, others don't, and so others do a mixture, and this kind of drives expectations away from each other within a period. Then to hypothesis 2 about stabilization. So here you see the median time series. If we take the median of all economies in one treatment, and this is the control treatment, treatment 1. So this is kind of a representative evolution of treatment 1. And we see, okay, we initialized above, and then it kind of converges already automatically, but then it keeps on converging to the target. Slowly, nothing changes when we appoint a central banker because there's no forecast published. And then we have the bad shocks, and actually most economies, or half of them, never recover from these shocks. So this just goes down. Then in treatment 2, we see, okay, at first it's the same, then we appoint a central banker, and then actually we go much quicker to the target. Then here there's some deviation because the human central banker turned out to give some weird forecasts, some too high forecasts, but then we stay there again. And also we recover now from the bad shocks. In treatment 3, we see it works similarly or even better, like there's no human that makes a mistake in these periods, and actually we remain around the target, and also we recover well from the shocks. In treatment 4, we see initially, accidentally, it goes down a bit, but then it keeps just fluctuating, and there does not seem to be so much convergence to the targets or more stabilization compared to treatment 1 as in the other 2 treatments. And also here, I should note, in stage 3, we actually switched the algorithm in treatment 4. So we were not so interested in random projections during these bad shocks. We thought it would be more interesting to see what if we had a history of random forecasts and actually bad credibility of the forecast of the central bank, and then the comeback shocks, but we switched to having this algorithmic forecast that makes more sense. Can then these forecasts that start out with bad credibility still save the economy? And it turns out, yes, people realized that these forecasts were actually now better, and they did start to coordinate on it more, and we do not have as many economies where we just go down forever, which is also interesting. Okay, then to look at this more in numbers, we define in stage 2, so this part before the bad shocks, measure for stabilization, so this mean square deviation from the target for inflation and output. Let me focus on inflation mainly here on the top. And we see in treatment 1, this is 1.6, in treatment 2 and 3, it's significantly lower. And in treatment 4, it's lower, but not statistically significant. So this confirms the hypothesis that 2 and 3 stabilize the economy in normal times, and 4, we do not find evidence that it does. And then some numbers regarding the severe economic stress. So we have in treatment 1, more periods at the effective lower bound, larger length of the recession, deeper recession because we just never recover, more periods of deflation, and also we had 3 out of 6 economies basically never recovering, so like a deflationary spiral. In treatment 2, there was one case where a subject had was just too pessimistic. The central bank forecaster subject was giving pessimistic forecasts in the bad shocks times, and this led people to coordinate also on a bad path and having deflationary spirals. But the other 5 subjects actually did try to steer the economy a bit to the target, and that worked. In treatment 3, all economies recovered. In treatment 4, with the bad reputation, so this is the initial credibility that they had compared to much higher in treatment 3. So initial at the start of stage 3, so when these shocks hit, the green line had very bad credibility because it was giving random forecasts before, but now it changed its regime, and even with the bad reputation, it turned out that it only had one deflationary spiral. Okay, then hypothesis 3 about stabilization and credibility. We do 2 counterfactual simulations, and this is again this mean square deviation table. The first 4 columns you already know, and then the 5th column here is a counterfactual 1, where we can just do a simulation where we say what if subjects would have done this and that. So we do not need to run extra treatment, we can just simulate it. And we say, what if the central bank would have had full credibility and the professional forecasters would just have always followed that? And additionally, if the central bank would have followed the data-driven forecast? So what we think is the most likely outcome, but that has no strategic motive. And there we see this would also have been desirable. So it is statistically significantly lower than treatment 1. So how can we think of this? This is the benefit of credibility, basically. So we do something that is just good forecast, but not really try to manipulate anything. And if that would have had full credibility, then we would have been more stable than if it would have no credibility. Why? If it would have no credibility, this is basically one interpretation of that would be that people fully ignore it. And if they fully ignore it, then we're basically back at the treatment where they're not shown it at all. So having no credibility with this data-driven forecast would be comparable to treatment 1. So from 1.6 to 0.7 can be seen as the effect of just credibility with a forecast that's trying to be accurate. Then what about the interaction of the strategic stabilization and credibility? So what if we now would have said, okay, there's full credibility again, subjects follow the published projection, and what if the published projection would have been according to this computer algorithm that we used in treatment 3? So then we can compare this second counterfactual with treatment 3 and with the other counterfactual. So first comparing it with the other counterfactual, we see, okay, both are full credibility, but if we now employ a strategic motive, we have much, much better even than we had before. So if you have full credibility, you should definitely try. Then this strategicness is actually very effective and you should do that. But then at the same time, if we compare this second counterfactual with treatment 3, then we basically have the benefit of credibility again. So it's the same algorithm employed here and there, but here the credibility was just endogenous. People believed it or they didn't. And if they would have fully believed it, then this same algorithm would have actually led to a more stable economy as well. So there we see the benefit of credibility with strategic projection. So we need some credibility to achieve this at all. Without credibility, we would be in treatment 1. And then the more credibility we have, it would have been even better. Okay, then finally, the fourth hypothesis about how is credibility being built up, how does it depend on past forecasting performance? And there we follow Lubas Peterson's and co-authors paper, where we basically say, okay, what if we define a binary variable 0 or 1, either a subject follows the published projection or it doesn't, and depending on whether it's very close to it. So if the absolute distance is smaller than some threshold, then we say he followed it, otherwise he doesn't. And then we do a panel regression on some controls, and among other things, the and the explanatory variable, the past forecasting performance, the most recent one, and we get the following. So this past forecasting performance, or how close was the last realization to what the public projection was thinking about that period, and we see that has a significant negative effect on credibility. So the lower this error, the higher the credibility. And then, so in terms of people utilizing it in the next period, after observing this, the probability of utilizing is higher when this variable is lower. And also we see persistence in the utilization, but in treatment 4 we also saw that after a big regime change in how the projection is formed, also credibility can change very quickly. Then I'm out of time, so I skip this and just conclude. So strategic inflation projections act as a focal point that can coordinate expectations. That was our first hypothesis that we confirmed. And this allows also the central bank to stabilize the economy, both in normal times regarding volatility and achieving the target, but also preventing bad outcomes during recessions. And we find that credibility is important precondition with these counterfactual simulations and support. We saw credibility we need to do something. Next, we saw higher credibility can be achieved with better forecasting performance. But if we would just try to achieve full credibility at the expense of dropping the strategic motive, as would be in the first counterfactual, that's not optimal. So actually treatment 3, where we balance the credibility, building up some credibility, but also have a strategic motive, had a better outcome. So yeah, thank you very much, and looking forward to your comments and questions.
Anybody have a question? Well, if I may then, that was fantastic. Thank you. Very interesting. Could you please bring us back to the treatments, just so I see again the strategic treatment?
Yes, please.
Yeah. So
one is the central bank subject, and in the other, the central bank subject's forecast is not published. So for comparability in each treatment, there's a central bank subject, but in treatment 3, instead we publish a number based on the computer algorithm that also uses these informations. And where the subject doesn't decide how to use the data-driven forecast and so forth, but where we just have an algorithm that looks at credibility and then put some weight on the data-driven and the required for target, something like that.
Okay. And in treatment 2, what was again the forecaster instructed about credibility?
So one of his goals is to maximize credibility, in addition to stabilize the economy, and he gets an index of how well his credibility is working, how much people were utilizing in the past his forecast, and he gets this data-driven forecast required for target.
And does he have like a welfare function to weigh them? So he's saying he has a few objectives.
Yes, so it does get an objective function. Let me see if I have that in an appendix. No, it seems that I don't have that, but that's indeed I think it's a weighted sum of square deviations of credibility from one end of inflation from target. So there's a weight on both these things. Yes.
And is it? I have a bit of a hard time understanding the third treatment and how it compares to the second. So the third one is all algorithmic. Is it again looking at the same functions and just taking an optimal choice, if you will?
Yeah, so we couldn't really come up with something that's optimal, but we just thought that we could do better than the subjects, maybe even with an algorithm. So we have basically we take the credibility index as the weights on the required for target or on the data driven. So if the credibility is 1, then we basically are fully strategic, and if the credibility is 0, then we fully try to gain credibility. And additionally, we say, well, if inflation is very close to the target, then we may as well just give the inflation target as the forecasted.
Okay.
That's switching.
And the first treatment was no credibility at all. The second,
so the first treatment was no publication at all.
no publication. Excellent.
And I told you later you could compare that with having a publication that's completely ignored.
Yeah, lovely. Could you show us again the time series and where they explode as if the spirals?
Yes.
So what's going on?
So the spirals I also have in more detail here. Or I can show you the other graph as well. These are just the individual lines.
Okay.
And the colors are, I guess, the treatments. So we see here some going down and some recovering. And what I showed you before, which is easier to look at, is just the medians of each treatment.
Yeah. Do you have any idea why they go down?
Well, so we give the very bad shock, and then they see, okay, output and inflation are very low, and then they have low output and inflation expectations, and that leads to then low realizations in combination with the shock still being there. And this is also something that we observe in learning models. So yeah, that was not surprising. Also in other experiments with the zero lower bound or effective lower bound, where you basically do not have policy stabilization, then it's easy to come in a region where negative expectations are self-fulfilling. There's nothing being done against them, and you just keep going down. And then we found, well, one way to get rid of this is actually having some forecasts being published that are a bit higher, so that people actually are not so pessimistic and expect some recovery, because the central bank tells them there will be a recovery, and then actually you do not end up in this spiral.
Yeah, excellent. I mean, that makes me feel a little bit better about my paper coming up later.
Okay.
Because at least it makes sense in the real world. So that's good to see. Any questions?
Yes, I actually have a question for Joep. I was wondering, with all the discussions now regarding central bank digital currencies, if you are planning to do some sort of experiment, in which expectations can be better managed with a digital currency?
So I haven't thought of this. That's interesting. So how would you say that? About what exactly should we manage then expectations in light of digital currencies?
Well, I was thinking, for example, people are planting it as a way of breaking the zero lower bound curves. And they also think it's a better way of managing liquidity and getting straight to households and firms instead of passing through the banking system. So I was wondering if you were planning of doing something on CBDCs.
Yeah, so not yet, but I'm sure people are thinking of this as well. There are many macro experiments to this, but yeah, that's interesting. I will think of this. Thank you.
Any other question? Another 2 points that I have, which the first one is about the zero lower bound. Have you studied its effects on the expectations and stability of the system? Is it, if it's longer, if it's shorter? Do people understand it well? What if you give them the same shock with and without the zero lower bound? Would they have different expectations?
So interestingly, I'm running another experiment currently where people, where we either tell people that they're about to interest rate or not. So we show them output and inflation, and then we either show them in the treatment the interest rate or not. And again, we make the zero lower bound binding. So in some treatments, they are not explicitly aware that the zero lower bound is binding, and others they are. And also in a third treatment, we present them with like what would the interest rate have been if there were what would the interest rate have been if the zero lower bound was not there, if we could have negative interest rates as an additional piece of information. And there we actually we run this partly with with PhD students and staff, and basically, and also with master students. But basically, we see it depends very much on what they know. So we have a question like about what is a liquidity trap, and people that know what this is, they're negatively affected by seeing the zero lower bound. So they then have more pessimistic expectations if they see the zero lower bound is binding. And people that do not know what the liquidity trap is, that ask that question wrongly, they basically just have similar expectations as in the treatment where they do not see the interest rate.
Yeah, I see. That sounds quite interesting. One thing that pops into mind is perhaps asking them afterwards, so asking the question, just the liquidity trap kind of could be a treatment in itself, the wording. But maybe you've done that, asking some people after the fact and some people before.
Yeah, so we just have a series of questions at the beginning about their macro knowledge, and there are 10 questions and about interest rate setting, banks, and so forth. And one of them is what is a liquidity trap? And so we're not really priming them on this too much, but we're just interested in their knowledge. So we also looked at other questions, but this question seems to be very much explaining how they react to the different treatments.
Yeah, I bet. I mean, it's fairly narrow. There was an interesting talk at Oxford actually a week or two ago by Dmitry Sergeyev with Gornichenko, and one of the about inflation expectations of agents and the zero lower bound actually on inflation expectations. And one of the topics that popped up then was, you know what, we probably don't really care on a macro scale about the households expectations. It's really about the professional forecasters. Now, that's a hotly debated topic, but it's something to keep in mind, whether the central bank should really be worried about households not understanding the liquidity trap, or maybe you could have households and you could have professional forecasters somehow in the model, and they have different roles. I don't know, but it's something to think about.
Yeah, definitely. I've also been thinking about exactly this.
And the last thing I promise, and then we can just open the floor if anybody has any questions for the presenter, is the credibility index and the function, the welfare function, if you will, of the bank really reminds me of policy inertia. That the central bank might think, you know what, if I move the interest rate a lot, or if I make this in this projection, I might change the perception of the people, or essentially my credibility index. So could you perhaps study whether policy inertia comes out as a result of such incentive device of credibility index?
Yeah,
So
like as an optimal outcome or something.
Well, yeah, I guess, like, suppose there is a rho I -1 in the Taylor rule. There is some smoothing.
Yeah.
And instead of imposing it on the bank and perhaps changing the Taylor rule in some way and doing doing just discretion, could we get some sort of inertia coming up on its own just by the central bank having this credibility index in mind?
Yeah, but by having this objective, whether it would then be optimal to have a positive inertia.
I think the Koibon and Gornichenko 2012 paper that studies inertia really argues that, you know, they say, is it inertia? Is it persistence in the shocks? Why do we see so persistent interest rates? And they argue it's probably inertia. And one of the reasons may be credibility or reputational things.
Yes, thank you.
All right.